Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Xin Yang version 2 by Puzzle Tank. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and 3x3 region. We have crop key dots, where digits separated by a white dot must be consecutive, and not all white dots are given. So, for example, if this were, say, a 6 here, this would have to be a 5 or a 7 here to be consecutive with it because there's a white dot between them. And that's how white crop key dots work. We have arrows, where digits along an arrow must sum to the 2-digit total given in the arrow's attached pill. And the 2-digit values in the pill is read from left to right. So, for example, say this was an 8 and a 9 here. Then this would have to add up to 17, where it's read from left to right. So this is the tens digit, and then that's the ones digit. And that's an example of how arrows work. And finally, well, we don't have finally. We have yin yang shading, where we need to shade some cells such that all shaded cells are orthogonally connected, and all unshaded cells are orthogonally connected, and no 2x2 area can be either entirely shaded or unshaded. So this is an example of a valid yin-yang shading, because so what does it mean to be orthogonally connected? It just means you can go from any cell in a region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from here to here, you can just go along these edges here and stay within the shaded region. To get from here to here, you can go along these edges here, all while staying within the unshaded region. This is an example of an invalid yin-yang shading because this cell blocks these cells from connecting to the rest of the unshaded cells. They have to either exit by going through a corner or go through an edge but exit the region, which is not allowed. And this also would be an invalid example of a yin-yang shading because we have a 2x2 area here which is entirely shaded, which is not allowed. Okay, now what does the shading do? Each arrow total is a 2-digit number to be read as x, y. The x value, which is the tens digit, indicates how many shaded cells can be seen from that cell in only the horizontal direction, including itself. The y value, which is the ones digit, indicates how many unshaded cells can be seen from the cell in only, it's misspelled, vertical direction, including itself. And the other shading blocks vision. So x counts how many shaded cells can be seen from that cell in only the horizontal direction. So the problem in other shading blocks vision. So therefore, this would actually be 0 in this case for the shading. This would see, 1, 2, 3, 4, 5, 6, 7, 8. So this would have to be 8 that it sees in that direction. It sees in the horizontal direction. This sees how many cells, unshaded cells, can be seen in the vertical direction. So I think this would be 2 in that case here. And so this is an example of how this would work. This counts all the shaded cells in the horizontal directions, excluding ones blocked by the other shading. So that would be 8. This would see 2 cells that are unshaded in the vertical direction, and it's blocked by these cells here. So that's why it would be 2 there. Also, cells separated by crop key dots must be of opposite shading. So these have to be opposite shading here. And these must be opposite shading, which is correct. This is opposite shading, which is correct. These have to be opposite shading here also. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the sum of these two digits is equal to the sum of all the digits in this box, which is guaranteed to be 1 through 9. So 1 through 9 adds up to 45, so this is 4 and this is 5. This is consecutive with 4, so this must be 3. These are of different shadings here. This must see only 4 shaded cells here. So it could see 4 shaded cells this way. It could see 4 shaded cells this way. It could see potentially 4 shaded... Yeah, I think we already did that. 4 shaded cells this way, 4 shaded cells this way, 4 shaded cells this way. Or potentially 4 shaded cells here, here. This is a different shading, different shading, different shading, and different shading. Okay. This is adding up to a teen number. So it could be 12. Okay. This has to be 1 as a teen. And this has to be either 13, 15, or 17. Because these are consecutive with each other. So 1 is odd and 1 is even. So it must add up to an odd sum. So that leaves 3, 5, or 7 there. Same with this. This is 1 here because this is a teen at most, 17 at most for 2 digits. This can't be 1, so this has to be 20 something. And this could be either 23 or 24. Either way, 23 and 24, because 3 digits at most, and they have to be different digits, must add up to only at most 24. Either way, it's going to be 7, 8, 9, or 6, 8, 9, adding up to 23 or 24, which means we need an 8 somewhere on this arrow. 8 can't be here because of 8 in the column, so this must be 8 here, which means this is an even cell, so this must be a 7 or 9 here. It cannot be 9 because we need 7, 8, and 9 to add up to 24, or 6, 8, 9 adding up to 23 here. So this can't be 9, which makes that a 7. So this has to be a 6, 9 pair here, adding up to 23. Oops. 23. That means the remaining digits in this lower right-hand box are 1 through 5. No 5 here because of 5 in the row. So this sees 5 odd cells in the unshaded cells in the vertical direction. So these are guaranteed to be unshaded. I don't know how it does, including itself. So these are all unshaded. This sees 1 shaded cell in the horizontal direction. This sees 3 shaded cells in the horizontal direction, or sorry, vertical direction. This adds up to at most 20 something, but this could be 1 or 2. 8 has to be one of these 3 digits there. 7 eliminates 7 here. So what are the possibilities here? 13 has to be 6 and 7 added together. So that would be 6 and 7. 15 must be 7 and 8 added together, but this can't be 7 or 8 because of 7 or 8 in the column. So this must be then 7 and 6 adding up to 13. So this sees 3 unshaded cells in the vertical direction. This is 3, so one of these two is 3 here in row 5, because we can't have a 3 remaining here. In column 5, we can't have a 3 here because of 3's in the boxes, so 3 has to be one of those 3 there. Remaining digits of column, this is 1, 2, 3, 4, 5. So this adds up to 30-something at most, 35 at most. So this is 1, 2, or 3. 1 in row 6 cannot be here because of 1's in the boxes, so 1 has to be one of those 3. So this sees 4 shaded cells somewhere in row... Okay, so one trick, or I guess not trick, it's a deduction that you can make about yin-yang shading is you can only have 0 or 2 changes of shading on the edge of the grid. And this is because of how yin-yang works. We have to have one completely orthogonally connected region of shaded cells and one completely orthogonally connected region of unshaded cells. So what happens if we try to break this apart into shaded and unshaded, but we have multiple changes, we have more than 2 changes of shading? Well, we always have to have an even amount of changes of shading, because if you change shading once, you have to change back some other time, right? But what happens if we have 4 or more than 2 changes of shading? Well, try to orthogonally connect the shaded regions. If you try to do that, you'll break the unshaded regions into 2 separate regions, guaranteed at least. Same if you try to connect the green regions orthogonally, you'll break the blue regions into 2 separate regions, which is not allowed by yin-yang shading. That's why we know we can only have 0 or 2 changes of shadings on the edge. Well, this sees only 4 cells in this row here that are shaded. That means there's going to be a change of shading here. This sees only 1 or 2 cells in a change of shading this way. So that means there's a change of shading somewhere in row 9. So if we try to see 4 going this way, the problem is that you would have a change of shading here and then a change of shading here, which would mean we have 2 changes of shading already there. So it cannot be going that way. It has to be going blue going this way. We have a change of shading here, and then this is green. So this sees 5, therefore this would be blue here, because we only see 5 in the vertical direction, and then the change of shading blocks vision. This must see some change here, and it's 1 or 2. So this has to be blue going this way. And then we have a change of shading here to green, which means all of these are green up to here. And it must include up to there. Well, we have now 2 by 2 areas that have 3 of one color, which means that the last one has to be the other color. So this is green. This has to be blue because we have 3 greens here. This is 3 greens, so this is blue. Same with this. This is green, so this has to be blue. This has to be blue here because it sees 5 in the vertical direction. This sees 1 in the horizontal direction, so it cannot be. It sees itself, and then this must be green. We don't know if this is 1 or 2. It could I don't even know if it can. Yeah. This sees 1 in the horizontal direction. This sees 3. So if we try to go, it could be 1, 2, 3 technically there. This could see 3 that way, potentially. Oh, this sees unshaded cells, so this must be 9 here. Right? It sees 9 unshaded cells in the vertical direction, including itself. So this cannot be 39 because this is a sum of 5 unique digits, which can only add up to 35 at most. So this is 19 or 29. What else do we know? These are different shades. Sees 1 in the horizontal direction. This sees 2, including itself. So it's either 2 that way or 2 that way. I'm not sure which. These are different shadings. If this is green, this has to be blue and blue. If this is blue, that must be green. That doesn't help us much. 6 in row 1 cannot be here because of 6 in the box, so 6 has to be one of those 3. Okay, remaining digits of column 6. We have 2, 4, 8, and 9 available. This can't be 4 because of 4 in the box. This can't be 2 because of 2 in the box. Remaining digits of column 8. We have 1, 2, 3, 4, 5, 7 as possibilities. This can't be 3 because of 3 in the box. There's no 3 here because of 3 in the column. This can't be 4, 5 because of 4, 5 in the row. This is not 2 because of 2 in the row. These can't be 1s because of 1s in the row. Okay, this can't be 7 because of 7 in the row. This only sees 2. So it must orthogonally connect to the rest of... I guess it could do something like that. That is potentially possible. No, because then that would see 3. So it could do technically something like this? Yeah, that's possible. Okay. 9 can't be here because of 9 in the column. 9 can't be here because of the 6, 9 pair in the column. So 9 has to be one of these 2 digits there. Okay. These digits are consecutive. You can't have 8, so no 8, 9 or 7, 8. But you could have 6, 7 here. You could have 1, 2, 3, 4 here. No 3 or 4 here. So this can't be 4 because that would be consecutive only with 3 or 5. And this can't be 3 or 5 because of 3 or 3 in the column, 5 in the box. Okay. This cannot be 1, because if this is 1, 1 plus 9 adds up to at most 10. This can't be 2 for the same reason. 2 and 9 at most adds up to 11, which this cannot be. If this were 3, the problem with this being 3 is that would eliminate 3 from being there, and then this would have to be 13. But 13, to add up to 13, it would have to be 3 and 10, which is not a single digit. So this cannot be 3. So this has to be 6 and 7 to be consecutive with each other, which eliminates 6 and 7 in the rest of the row. So this can't be 6, it's 9. That means this can't be 9, that's 6. Okay. This adds up to at least 12. So this cannot be 5 or less because 5... Oh, sorry, could be 5. Can't be 4 or less because 4 plus 7 at most adds up to at most 12. Or sorry, 11. Which this has to be at least 1 plus another digit, which would be 12 or 13. So it could be 5, can't be 7, could be 6. Could be 5, 6, 8, 9 here. Also, remaining digits of row 7 have to be 1 through 4. Because of 1 through 4 in the... we have a 6, 7 pair in the row and a 5, 8, 9 already in the row. This can't be 2 because of 2 in the column. This can't be 1 because of 1 in the column. Okay. So this adds up to, it could be 12, 13, 14, 15, or 16. So this is 2 through 6. This has to be, it cannot, okay, you can see at most 6 digits here. So this could be 1 through 6 that way, vertically. This sees 3 cells that are unshaded. It cannot be these 3. Can't be these 3. So these 3 doesn't work because we have 2 by 2 areas that would be all unshaded. So not those 3, not those 3. It could be these 3, so that means this is guaranteed to be unshaded. And then it could just be those 3 that way. It cannot be these 3 there. So it's either these 3 here, or it sees these 3 there. This sees 3 also. 5, 2 through 6. If this were 1, this would have to be 2. But then this would see only 1 that's unshaded here. So we have, this would have to be C2, so it would see 2 there. Therefore, this would have to be green. But then the problem is this would see only 1 unshaded cell in the vertical direction. So this would have to be blue. This is another deduction you can make about yin-yang shading, is if you have a cross pattern of a diagonal that's 1 shade, the other diagonal cannot be the same shade, either whether it's the same shade as this or different shade as this. And the reason why you know that is, so let's try diagonal, just a random one here. If this is green, if we try to make these both the same shading of green, obviously you have a 2 by 2 area that's all green, which is not allowed. Now, if you make it blue of the same shading, what happens if when you try to orthogonally connect the blue regions? you will necessarily break the green regions into two separate regions, which is not allowed. Same if you try to orthogonally connect the green regions. What happens to the blue regions? You will necessarily break the blue regions into two separate regions. So, if we try to have a 1 here, the problem is that gives us the deadly pattern of a diagonal, which is one shade, and the diagonal of the other shade being that different shade. And that's not allowed. So this cannot be 1. So we cannot have 21 here. We still could have 23. Or 24 is potentially possible, and that would force us to be 7, 8, 9. Hmm. Okay, so this is not 1, so it must be green going this way. Can this be 12? If we have 12 here, that would force this to be 3, 4, 5 as a triplet because there's no 1, 2 here. That would mean this is 6, 7, 8, 9, which is not going to work because that adds up to, at minimum, 21. So this cannot be 2 here. So this must be seeing 3 greens in the vertical direction. So this is green, which makes this blue. We have a diagonal here that's all blue, so one of these is blue and then the other one's green. We're not sure which. This 2x2 area has 3 greens in it, so this must be blue. These are different shadings, so that's why this is blue there. This sees at least 3 going that way. So this cannot be 5. If this is... I guess it could be 5. So it could be 23, 24, 13, 14, 15, or 16 here as possibilities. Okay. If this is blue, that makes this green. If this is blue, that makes that green, which would make that blue. Interesting. Hmm. Remaining digits in this upper central box, we have 1, 2, 8, and 9. No 9 here because of 9 in the row. No 2 here because of 2 in the column. No 8 here because of 8 in the row. Okay. We have a 1, 2, 8 triplet, which eliminates 1, 2, 8 in the rest of row 3, which leaves this as 3, 4, and 5. 3, 4, and 5 is only consecutive with 2, 3, 4, 5, and 6. Interesting. So 6 and 7 in this lower central box cannot be here. So it must be either here or on the arrow, which is interesting. 5 in column 4 cannot be here because of 5 in the box can't be here because of 5 in the box, so 5 has to be one of those 3. This can't be 3 because we have 3 in the row. So if we have 3 here, that's 2 and 4. If we have 4 here, that's 5. If we have 5 here, that could be 4, 6. So that's fine. Remaining digits in this upper left-hand box, we have 1, 2, 6, 7, 8, 9. And 6 and 8 cannot be here because of 6 or 8 in the row. 1 can't be here because of 1 in the column. 7 can't be here because of 7 in the column. Therefore, one of these 3 digits is an 8, which eliminates 8 from being here. So that's 2 or 9. Remaining digits of column 7. We have 1, 2, 4, 5, and 9. These can't be 9 because of 9 in the box. This can't be 4, 5 because of the 4, 5 in the row. We also have a 1, 2, 7, 9 quadruplet in row 2, which eliminates 1, 2, 7, 9 in the rest of the row. So this can't be 1, 2. It's 4, 5, which makes this 4 or 5 there. We have a 1, 2 pair in this upper right-hand box. That eliminates 1 and 2 in the rest of the box. So this must be 3 and 7 as a pair. That eliminates 3 and 7 in the rest of the row. So this cannot be 7 here, which means one of these two is 7 here. Okay. No 2 here because of 2 in the row. No 1 here because of 1 in the row. Hmm. 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 If this is 3 greens here, that means this sees a 2 by 2 area that has 3 greens, so therefore this must be blue. If this is 3 greens this way, we have to orthogonally connect the blue cells. So therefore, these would have to all be blue to orthogonally connect because this would block the green, this blues from orthogonally connecting this way. So either way, this is blue. So this is blue, which makes this green. 3 greens there means this has to exit out that way, so that's blue. If this is 3 greens here, we have to go blue here and then orthogonally connect, so these are blue no matter what. This sees, again, 3. This sees 3. Hmm. 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 Only one of these is going to be blue. Either this is blue and that's green, or this is green and that's blue, and then this would be green. So we know these are different region or different colors. This both cannot be green. So one of these is blue. And if we try to have a blue here and a blue there, If we try to have this be blue and this be green, the problem is this would have to be green and this would be blue. So it cannot see both of these as... You cannot have two greens here. They can't be the same shade because it's 2x2 area. And we can't have one green and one blue because we would lead to the deadly pattern we have for yin yang shading. So this must be two blues. So this is two blues, this is two greens. You cannot see a green here because then that would be see four unshaded cells there. So this is blue, this must see three that way, and then this is blue. So this is all blue there. This must see a shaded cell, so it has to see then 1, because this is the only shaded cell it sees. Can't see that, can't see that. It's blocked by that. 1 eliminates 1 here, so this is 8, which makes that 2. 2 eliminates 2 here, so it's 9, which makes that 1. 1 eliminates 1 in the rest of the column. 9 eliminates 9 in the rest of the column. 1 eliminates 1 here. So... And it also eliminates 1 here. So these 5 add up to 19 here. What's the minimum right now? We have for 5 digits without a 3. It's 1, 2, 4, 5, 6. Well, that adds up to 18. So that means the 6 can only go up 1. So it has to be 1, 2, 4, 5, 7, adding up to 19 without the 3. So this can't be 2, 4, 5. It's 9. We have to have the 1 as part of this set. So this must be 1 there. That eliminates 1 here, so that's 2. That means this can't be 1 or 2. It's 4, 5. This has to then be 2, 4, 5, or 7, which means this can't be 8. That leaves these as a 6, 8 pair, which eliminates 6 and 8. Well, we don't have any information there. Okay. Okay. We go that way. This connects that way. That seems fine. If we go that way... I guess that's fine too. One of these digits has to be a 2. We're not sure which. Two eliminates 2 in the rest of the row. We have no more 9 either, so it's 1, 6, 8 as a triplet, which eliminates 1, 6, 8 in the rest of the box. So this can't be 1, it's 2, 7, 9. This is blue, so this must be green here. This is a 3x3, that's all green. A 2x2, that's 3 green, so this is blue here. So this sees 4 horizontally, 5 unshaded vertically, 1 horizontally. We don't know what that is. This could be 1 or 2 horizontally. This is at least 3 vertically, 2 horizontally, 3 vertically. So it's either those 3 or those 3. 3 vertically, 1 horizontally, 9 vertically, 1 horizontally. Okay. Remaining digits of row 6. We have 4, 5, 6, 8, 9. No 4 here because of 4 in the column. And that's all we really have. How is this very easy? This is quite convoluted, just to even get through. Blue, to orthogonally connect, blue has to go through this cell. So then this is blue, which means this cannot be blue here because we only see 2 blues until we're blocked by unshaded cells. So this is green, which means the 3 greens that it sees are here. This must connect orthogonally that way. It's blue. This is a 2x2 that's all blue, so this must be green. Blue has to orthogonally connect this way, so that's blue there. We have to orthogonally connect this way, so that's blue there. This sees at least 4. So this sees 2 cells horizontally that are shaded. This sees 3 cells horizontally that are vertically that are unshaded. That's satisfied. Okay. Remaining digits of column 5. We have 3, 4, 6, 7, 9. No 3 here because of 3 in the box. No 9 here because of 9 in the row. No 6, 7 here because of 6, 7 in the row. And that's pretty much it. Okay. So this adds up to 14, 15, 16, or 24. Those are the possibilities. If we try to have a teen, it can't be 14 or 15. Because if it's 14 or 15, that would mean we have a 1 through 5 quintuplet here, which leaves 6, 7, 8, 9 here. So this adds up to either 16 or 24. Because 6, 7, and 8 at minimum adds up to 18. Or sorry, 21 at least. So, can we have... So this cannot be 15. It cannot be 25. So this is 4 or 6. Can we have 16 here? If this is 16, this is 7, that's 6. We have a guaranteed 7 on this. No 1, obviously. So 16 minus 7 means we have 9 left. So it cannot be 1, 8, cannot be 2, 7, can't be 3, 6. It would have to be 4 and 5 with the 7 to add up to 16. But that's not allowed because of 5 in the box. So then this has to be 24. So we see 20 and 4 here. This sees 2 shaded cells in the horizontal direction. This is a 2 by 2 area. This sees 4 in the vertical, unshaded in the vertical direction. So that's blue. This diagonal is green, which means we cannot have 2 blue here, so this must be green that way. This is a 2 by 2 that's all green, so this can't be green there. It's blue. 2 by 2 that's all blue, so this can't be blue. It's green. This sees 4 unshaded horizontally. Hmm. How does the shading go this way? This is not very easy. I don't know why people graded it that way. Anyways, this sees, it cannot see more than 16. It could see 5 potentially. So not 6. 2 eliminates 2 in the rest of the column, so this is not 2, it's 9. This is not 2. These can't be 2. This is 2 and 4, which eliminates 2, 4 in the rest of the row. So this must be 5. This can't be 2, 4, 5. It's 3. This can't be 2, 3, 4, 5. It's 1, which makes this a 2, 4 pair here. That eliminates 2 and 4 in the rest of the column here. 5 eliminates 5 here, so this is 4 and 5. 2, 4 eliminates 2, 4 here. This can't be 5 because of 5 in the column, so it's 7, which makes this not 7. That's 3, which makes that 7. That's 7, can't be 7 here. 7 eliminates 7 in the rest of the row. This can't be 9, no 9 there. 4 eliminates 4 in the rest of the box, so this can't be 4, it's 3. This can't be 3 or 4, it's 1. 3 eliminates 3 here, so that's 4, which eliminates 4 here, so that's 2. This is 24, so this must be 7, 8, and 9, adding up to 24. So we have 8 there, and this must be 7 or 9, no 3. This is 7, 9 as a pair also. That leaves 6 remaining in row 9. That eliminates 6 in the rest of the box, so this is 7, that's 6. This can't be 4 or 9, so this must be 3. This can't be 4 or 8, it's 2. 8 eliminates 8 here, so it's 4. That eliminates 4 in the rest of the box, so this is 6, 9, or 6, 7. This can't be 6 because of 6 in the column. Remaining digit in this lower central box is a 1. Remaining digits in row 8 are 5, 8, and 9. 6 eliminates 6 here, so that's 8, which eliminates 8 in the rest of the box. 1 eliminates 1 here, so this is 6 and 1. This can't be 6 or 8. This can't be 8. 7 eliminates 7 here, so that's 2, which makes this 7. That eliminates 2 here. This can't be 3. We have a 4, 5, 9 triplet in column 1, which eliminates 4, 5, 9 in the rest of the column. So this can't be 4, 5, or 9. It's 2, which eliminates 2 in the rest of the row. So where's 2 in column 8? It has to be here. Okay. 4 eliminates 4 here. This is either adding up to 13 or 15. To add up to 13, it has to have a 6 here. To add up to 15, it must have an 8 there. We have a 6, 8 pair in row 6, which eliminates 6 and 8 in the rest of the rows, so no 8 here. It's 5 or 9. This sees at least 3 cells in the vertical direction that are unshaded, so this is unshaded there. If we have this as shaded, this must be unshaded, but then the blue is not orthogonally connected to each other. So therefore, because this is blue, this is green, and then the blues don't orthogonally connect. So this can't be blue, this is green. This must orthogonally connect that way. This must be blue. We have to orthogonally connect one of these as blue and then green. We don't know which. Okay, 4 eliminates 3, 4, and 4, 5 as consecutive digits. So this must be 5, 6. 5 eliminates 5 here, so it's 4. This can't be 4, 5. It's 3. 6 eliminates 6 here, so it's 8. Therefore, this 8 and 7 add up to 15. This must be 5 greens that it sees, so this has to orthogonally connect as the blues that way. And if you notice, the blues now are all orthogonally connected, as are the greens. 5 and 8 eliminate 5 and 8 here, so it's 9. That leaves this as a 3. 8 eliminates 8 here, so it's 6 and 8. 4 eliminates 4 here. And this can't be 5 because of 5 in the box, so this is 9, which makes this 5. This can't be 5 or 9, it's 8. That leaves the remaining digit in column 2 as a 4. 4 eliminates 4 here, so it's 5, which makes that 4. 9 eliminates 9 here, so it's 5. 6 eliminates 6 here, so it's 9, which eliminates 9 here, so it's 7 and 9. 7 eliminates 7 here, so it's 6. 2 eliminates 2 here, so it's 4. That leaves this as an 8. And this as a 7. That was not very easy. I don't know what people are smoking. It's just, this is not a very easy puzzle. I think I would consider this challenging, even. The logic behind this isn't necessarily the easiest either. Also because, I mean, I did assume that you could see something as long as this is blocked, right? If you can see that. But maybe that makes things easier if that's the case. But even then, it's still not a very easy puzzle. I think I'm going to label this as challenging because I don't think this is a very easy puzzle. But I hope you guys got through this with me and understood the logic behind it. I was hoping this would be a nice introduction to Yin Yang shading, but I don't think it is. Because it's much more difficult than very easy. I'm not sure what the graders or the raters are thinking when they rate this as very easy. Anyways, I hope... Oh, maybe this was... No, this was a very... Yeah. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, even though it was quite difficult. And I'll see you next time on Frank Puzzles. Take care.